This is SpaceTime Series 27, Episode 62, for broadcast on the 22nd of May 2024. Coming up on SpaceTime, a new Earth-sized world found orbiting a nearby ultracool star, discovery of a stellar slow lane on the Milky Way's outer edge, and trying to reveal dark matter's ghostly effect on stellar streams. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered a new Earth-sized planet orbiting an ultracool red dwarf star just 55 light-years away. The findings, reported in the journal Nature Astronomy, represent only the second Earth-like exoplanet discovered orbiting a spectral type M red dwarf. The other being Proxima b, which is 1.07 times the mass of the Earth and orbits the nearest star to the Sun, Proxima Centauri, located just 4.265 light-years away. This newly discovered world, called Speculus-3b, takes around 17 hours to complete each orbit around its host star, Speculus-3. Now, being a red dwarf, the star has just half the surface temperature of the Sun and just a tenth of the Sun's mass and only 1/100th of the Sun's luminosity. The study's authors say days and nights on Speculus-3b would be endless. That's because the planet's likely to be tidally locked to its host star, so that one side's always facing the star and the other side's in perpetual darkness. It's the same as our moon being tidally locked to the Earth, with the same side always facing our planet. The discovery of this new exoplanet was made by the Search for Planets Eclipsing Ultracool Stars, or Speculus project. It was established to search for exoplanets orbiting ultracool dwarf stars using a network of robotic telescopes around the world. Red dwarfs are the most common types of stars in the known universe. In fact, they make up around 75% of all the stars in the Milky Way. Trouble is, they're very faint and scattered across the sky, so astronomers need to observe data from telescopes over several weeks, monitoring each star individually in order to detect a transiting planet. That is, a planet passing in front of the star, blocking out some of its light, as seen from Earth, as a sudden dip in starlight and then a return to normal. The study's lead author, Michael Gillen from the University of Liège, says it was their prototype equipment for Speculus which discovered the famous TRAPPIST-1 system, which is made up of 7 Earth-sized planets, several of them potentially habitable. So, why specialise in looking for spectral type M red dwarfs, other than the fact they're so common? Well, they're far cooler and smaller than the Sun, and so burn through their nuclear fuel supplies really slowly. In fact, as far as we know, throughout the entire 13.8 billion year history of the universe, no red dwarf star has lived long enough yet to run out of fuel. They're expected to keep shining for trillions of years, thereby lasting long enough to become the final stars shining in the cosmos. And scientists believe it's this long lifespan which offers opportunities for life to develop on planets orbiting such stars. But there is a problem. These stars are also very violent, often erupting with powerful stellar flares capable of irradiating the surface of any nearby planets. Still, the Speculus team believe it's worth a look. They'll now be looking for telescope time on the Webb Space Telescope in order to study this particular planet in greater detail, providing important insights into its surface mineralogy and the potential of the planet to have an atmosphere. Needless to say, we'll let you know what they find. This is SpaceTime. Still to come, a stellar slow lane on the Milky Way's outer edge, and a new observatory to reveal dark matter's ghostly effect on stellar streams. All that and more still to come on SpaceTime. A new study suggested stars orbiting along the outer edge of the Milky Way's disk are travelling more slowly than those orbiting closer towards the centre. The findings, reported in the monthly notices of the Royal Society, raised the surprising possibility that the Milky Way's gravitational core might be lighter in mass and contain less dark matter than previously thought. The new results are based on an analysis of data taken by the Gaia and APOGEE instruments. Gaia is an orbiting space telescope. It tracks the precise location, distance and proper motion across the sky of more than 1 billion stars throughout the Milky Way galaxy. The Apache Point Observatory's Galactic Evolution Experiment, or APOGEE, is a ground-based survey measuring extremely detailed properties of more than 700,000 stars in the Milky Way, such as their brightness, their temperature, and their elemental composition. The study's authors analysed Gaia's measurements for more than 33,000 stars, including some of the furthest, most distant stars in the galaxy. And they determined each star's circular velocity, that is, how fast the star is circling in the galactic disk, given the star's distance from the galaxy centre. The authors then plotted each star's velocity against its distance to generate a rotational curve. Now, the shape of this curve should give scientists an idea of just how much visible and dark matter there is distributed throughout the galaxy. One of the study's authors, Lena Nisib, says the team was surprised to see the curve remain flat out to a certain distance, and then it started tanking. Now, this means the outer stars are orbiting a little slower than expected, which is a surprising find. The team translated the new rotational curve to the distribution of dark matter that could explain the outer star's slowdown, and they found the resulting map produced a lighter galactic core than expected. In other words, the centre of the Milky Way may be less dense with less dark matter than scientists had previously thought. Nisib says this puts the results in tension with other measurements. It means there's something strange going on somewhere, and scientists need to figure out what it is and where in order to have a more coherent picture of our Milky Way galaxy. Like most galaxies, the Milky Way spins like water in a whirlpool, and its rotation is driven in part by all the matter that swirls within its disk. Back in the 1970s, astronomer Vera Rubin was the first to observe that galaxies rotate in ways that cannot be driven purely by visible matter. She and her colleagues measured the circular velocity of stars and found that the resulting rotation curves were surprisingly flat. That is, the velocity of the stars remained the same throughout the galaxy rather than dropping off with distance. They concluded that some mysterious type of invisible matter must be acting on distant stars to give them the additional push. Rubin's work in rotation curves was one of the first strong pieces of evidence for the existence of dark matter, an invisible unknown entity that's estimated to make up maybe 80% of all the mass in the universe. In other words, everything we see and know about our universe, from stars, planets and nebulae through to cars, people, trees, dogs, cats and houses, only makes up 20% at most of the universe's total mass. Since Rubin's work, astronomers have found similar flat curves in other far-off galaxies, further supporting the existence of dark matter. But only recently have astronomers attempted to chart the rotation curve of our own galaxy with stars. Trouble is, it turns out to be really hard to measure a rotation curve when you're sitting inside the galaxy you're trying to study. In 2019, astronomers charted the Milky Way's rotation curve using an earlier batch of data released by the Gaia satellite. That data release included stars as far out as 81,000 light-years from the galactic centre. Now, based on these data, the team observed that the Milky Way's rotation curve appeared to be flat, although with a slight decline similar to that in other far-off galaxies, and therefore by inference, our galaxy likely bore a high density of dark matter in its core. But thanks to new Gaia data, this view is now shifted. A new batch of data includes stars as far out as 100,000 light-years from the galactic core. And at these distances, astronomers are looking at the very edge of the galaxy where the stars start to peter out into intergalactic space. And up until now, no one's explored how matter moves around in this outer galaxy region. So Gaia's new data is expanding on that initial rotation curve. To refine their analysis further, the authors complemented the Gaia data with measurements by APOGEE. They estimated the precise distances of more than 33,000 stars, and they used these measurements to generate a three-dimensional map of the stars scattered across the Milky Way out to a distance of around 100,000 light-years. They then incorporated this map into a model of circular velocity in order to simulate how fast any one star must be travelling, given the distribution of all the other stars in the galaxy. They then plotted each star's velocity and distance on a chart to produce an updated rotation curve of the Milky Way. Instead of seeing a mild decline like previous rotation curves, the authors observed that the new curve dipped far more strongly than expected at the outer end. This unexpected downturn suggests that while stars may travel just as fast out to a certain distance, they then suddenly slow down at the furthest distances. The stars at the outskirts of our galaxy appear to be travelling a lot slower than expected. When the team translated this rotation curve to the amount of dark matter that must exist throughout the galaxy, they found that the Milky Way's core contains less dark matter than previously estimated. Understanding the new results will have deep repercussions. It might lead to more hidden masses just beyond the edge of the galactic disk, or a complete reconsideration of the state of equilibrium of our galaxy. This is space-time. Still to come, revealing dark matter's ghostly effect on stellar streams, and later in the science report, a new study confirms the iconic baobab trees originated in Madagascar. All that and more still to come on Space-Time. Well, let's stick with our theme of dark matter for a moment, and the Vera C. Rubin Observatory may well hold the answers to exactly what dark matter is. The telescope will provide astronomers with stunningly new detailed images that will illuminate distant stellar streams and their past encounters with a mysterious invisible substance. Now, as we mentioned earlier, dark matter makes up more than 80% of all the matter in the universe. Scientists know it exists because they can see its gravitational interaction with normal so-called baryonic matter, but they have no idea what it is. So to try and find out, they're using a variety of different indirect methods to investigate its properties. Some, like weak gravitational lensing, can map the distribution of dark matter on large scales across the universe. Observing stellar streams, glittering threads of stars around the Milky Way, allows astronomers to probe a different aspect of dark matter because they showcase the fingerprint of dark matter's gravitational effects on smaller scales. With images taken through 6 different colour filters mounted on the largest camera ever built for astronomy, the Vera C. Rubin Observatory's upcoming large survey of space and time will reveal never-before-seen stellar streams around the Milky Way and the telltale effects of their interactions with dark matter. As mesmerizing as rivers that glitter in sunlight, stellar streams trace sparkling arcs throughout and around our galaxy. They're composed of stars originally bound in globular clusters or dwarf galaxies, but which have been disrupted by gravitational interactions with our own galaxy and drawn into long trailing lines. And these slender trails of stars often show signs of disturbance, and astronomers suspect that in many cases, dark matter could be the culprit. The Vera C. Rubin Observatory will provide a wealth of data to illuminate stellar streams and hopefully their complex interactions with dark matter. Located in Chile, the observatory will use an 8.4-metre telescope equipped with the largest digital camera in the world in order to conduct a 10-year survey of the entire southern hemisphere sky beginning next year. The resulting data will make it easier than ever for scientists to isolate stellar streams among and beyond the Milky Way and examine them for signs of dark matter disruption. The co-convener of the Dark Matter Working Group in the Rubin Observatory, Nora Shipp from Carnegie Mellon University, says that Rubin will help scientists figure out how dark matter is distributed in our galaxy from the largest scales down to the very small. Right now, the evidence suggests that a spherical halo of dark matter surrounds the Milky Way, made up of smaller dark matter clumps. These clumps interact with other structures, disrupting their gravitational dynamics and changing their observed appearance. Now, in the case of stellar streams, the results of dark matter interactions could appear as kinks or gaps in the starry trails. The Rubin Observatory's incredibly detailed images will make it possible for astronomers to identify and examine very subtle irregularities in stellar streams, and thus infer the properties of the low-mass dark matter clumps that cause them, even possibly narrowing down exactly what type of particles these clumps are made from. Stellar streams in the outer regions of the Milky Way are especially good candidates for observing the effects of dark matter because they're less likely to have been affected by interactions with other parts of the Milky Way, which could confuse the picture. Rubin will be able to detect stellar streams up to distances 5 times further than what we can see now. That'll allow astronomers to discover and observe an entirely new population of stellar streams. So to isolate stellar streams, astronomers first search for groups of stars with specific properties that indicate that they likely belong together as either a globular cluster or a dwarf galaxy. They then analyse the motion and other properties of these stars, which will identify those connected as a stream. Now, among the 6 colour filters on the Rubin Observatory's 3200 megapixel camera is an ultraviolet filter. And that ultraviolet filter is important because it'll provide crucial information on the blue ultraviolet end of the light spectrum that will enable astronomers to distinguish subtle differences and untangle the stars in the stream from lookalike stars in the background field of the Milky Way. SHIP says Rubin will provide scientists with thousands of deep images, giving them a clearer view of stellar streams than ever before.
I'm really excited about using stellar streams to learn about dark matter. With Rubin Observatory, we'll be able to use them to figure out how dark matter is distributed in our galaxy from the largest scales down to very small scales. By observing stellar streams, we'll be able to take indirect measurements of the Milky Way's dark matter clumps down to masses lower than ever before, giving us really good constraints on the particle properties of dark matter. Right now, it's a really labor-intensive process to pick out potential streams by eye, and Rubin's large volume of data presents an exciting opportunity to think of new, more automated ways to identify streams.
That's Nora Shipp from the Carnegie Mellon University. She's co-convener of the Dark Matter Working Group in the Rubin Observatory and the Dark Matter Energy Science Collaboration. This is Space Time. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study has found that heat waves during the 4 hottest months of the year lead to more than 150,000 deaths around the world annually. The findings by scientists at Monash University looked at deaths going back over 30 years to 1990. The authors say this equates to some 236 deaths for every 10 million residents. The findings, reported in the journal PLOS Medicine, suggest that heat waves account for some 30% of all heat-related deaths every year. For Australia and New Zealand, the authors have estimated there are some 137 deaths for every 10 million residents each summer. The study found that heatwave-related excess death ratio and rate were the highest in locations with polar and alpine climates and lowest in tropical areas. Scientists have confirmed that one of the world's most iconic trees, the baobab, originated in Madagascar. These spectacular trees, which are instantly recognizable because of their unusually fat trunks, are found across Africa as well as on the island of Madagascar and are also common in the Kimberley region of northwestern Australia. The origins of these trees is not well understood, but now scientists have looked at the DNA and ecology of all 8 baobab species and say they probably first evolved in Madagascar before spreading to mainland Africa and then Australia. But all is not well for the Madagascan baobabs. The ecological data suggests that 2 endangered species there are highly inbred, meaning their genetic diversity is very low, and declining numbers of these trees mean that's likely to get far worse. You see, high genetic diversity makes plants more resilient to changes in climate and other ecological conditions, so these species are likely to struggle to survive as global warming continues increasing. Google's coming in for more sharp criticism after video went viral of the Google Nest Assistant refusing to answer basic questions about the Holocaust, in which 6 million Jews were murdered by the Nazis during and in the build-up to World War II. But Google's Nest had no problem answering questions about the Nakba, which refers to Arab states' rejection of the UN petition creating separate Jewish and Islamic states out of the traditional Jewish homelands, which triggered an Arab invasion of the newborn Jewish state in 1948. Instagram user Michael Affle asked the Google Nest virtual assistant, "Hey Google, how many Jews were killed by the Nazis?" And amazingly, Google responded, "I'm sorry, I don't understand." Now, the same token answer was offered to other related questions, such as how many Jews were killed during World War II, who did Adolf Hitler try to kill, how many Jews were killed in concentration camps, how many Jews were killed in the Holocaust, and what was the Holocaust? The video, showing how poisonous garbage in garbage-out computer programming has become, was posted to X by venture capitalist Josh Wolf. And while we're on the subject, the artificial intelligence wars are heating up, with the launch of both the ChatGPT-4 Omni and Google's Project Astra taking place just hours apart. But with a woke cancer spreading through tech companies and plenty of evidence that AIs can both lie and deceive, can anything that artificial intelligence tells us really be trusted? With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Well, last week we had a huge boost in AI. So we had ChatGPT launching GPT-4 Omni. Now, they didn't call it GPT 4.5 or 5.0, but it is a serious update over the previous GPT-4 Turbo and GPT-4 models launched in 2020. 3. So now the voice is much more human. You can now interrupt the voice. You don't have to wait 2 or 3 seconds for it to respond. It is able to see the world, a bit like the AI in the movie Her, which is only sort of 10 years old, and now we actually have an AI that can do that. And ChatGPT 4 Omni is going to be free. So if you were using ChatGPT 3.5 before and you were paying to get version 4, you can now get 4 Omni, which is even better, for free. Obviously, if you do pay, you'll get priority access. You'll only get limited access to 4 Omni. But this is a quantum leap in the capability of the AI. And Google struck back. I mean, OpenAI launched their version a day before the Google I/O conference, and Google showed very similar capabilities. They have an AI called Project Astra that can see the world. You can now search by video. So if something is happening, you can record a video and say, hey, what's happening here? How come my arm on the turntable is going straight to the end of the record? Why isn't it playing the record? Or you can ask it any sort of questions and you can show it photos or videos and it can give you an answer. It can generate video.
But Google's had a bit of a problem recently. You ask Google about the Holocaust and it has no information on that event. You ask it about Nakba and it has all the information you could possibly want. So there seems to be some sort of a disparity there about who's programming it and the garbage going into it and the garbage coming out of it. Until they fix things like that, can AI really be trusted for anything?
This is going to be an ongoing problem. But so far, both ChatGPT 4 Omni and Google Gemini 1.5 Pro, which has been updated from the previous version.
This is the one where George Washington was black.
Yeah, look, that's for sure. There's no question about that. I mean, we do have an issue where the AI has been programmed by woke people and is giving woke responses. But this is something that Google themselves are going to have to figure out. Because if they don't, people are going to choose ChatGPT 4 Omni. They're going to choose something from Apple. They're going to choose something from a range of different providers, even open source providers, who are going to be more trusted. So yeah, this is definitely a case of the battle of the AI and which AI can be trusted. Garbage in, garbage out. If the AI is woke and it gives you the wrong answers, then you are definitely right not to trust it. And this is going to be a big problem for AI systems in the future. But this is where there's a lot of work with open source AIs. You don't have to fully trust the AI's responses. You can ask it, you can demand.
Yeah, but people aren't going to do that. They're going to trust the information they're getting out of Google or whoever, whether that information's accurate or not, unfortunately. And we're going to keep having problems like this. There's got to be some sort of a gold standard that can be set where we know the data coming out of any AI is unbiased, trusted, and backed by history.
Well, look, this is a problem that humanity is going to have to face over the next few months and years, because if we are being fed incorrect information and thus people are then making the wrong conclusions and getting the wrong information and not understanding how history works, well, this is going to be a disaster. I mean, there's no question that garbage in, garbage out.
We can see it now on our university campuses.
Well, we certainly can. And this is where, we need to have a radical reset of what it means to get a genuine education, what it means to understand the lessons of history, what it means when people are fed the wrong information. And then there's the problem of wokeism. There's endless problems, which is propaganda that is giving people the wrong idea. I mean, this is a problem that's been around for humanity for, if not decades, centuries, millennia even.
That's Alex Zaharov-Reutt from TechAdvice.life. And that's the show for now. SpaceTime is available every Monday, Wednesday, and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.